Hello, and this is the last part of Unit 9. We're going to talk about epicenter location, where we need seismograms from 3 different stations, triangulation. This front page is actually showing you all the epicenters that we actually have in reference to any earthquake that's happened from 1898. And I was trying to get my kids today to try to figure out the difference between what is an epicenter versus a focus, and they seem to get those things confused, and I'm not exactly sure why. I did show them out this picture right here, and they told me it looked like Africa, although Africa is right there, and this looks sort of like South America and Africa, except South America's there, and this is the boundary of the North American, South American, African, and the Eurasian plate. Also talking about most of the earthquakes located over here on what's called the Ring of Fire. It is supposed to actually give you by magnitude. There are some bigger earthquakes. Biggest one should actually be down in here, but the fact that there are so many earthquakes in this convergent boundary, as well as a whole lot of earthquakes in this transform boundary, not a whole lot of earthquakes, and very linear in terms of the divergent boundaries. Next picture is actually showing you the largest earthquake since 1900, and talking about the largest one located there in 1960 in Chile, 1964 up here in Alaska, and 2006 over here in Indonesia, that caused that tsunami that knocked out 250,000 people. We have some other earthquakes not as large in terms of magnitude, but we actually had more death. But we're getting these things just like they were in this picture. They're not haphazard, although there are some earthquakes that are happen inside of plates. There seem to be a very decent pattern in them. So we talked about seismograms actually being the written record of a seismograph, which is actually going to measure seismic waves. I'm going to show them a picture of this Buenos Aires one. I talked about the difference between latitude in terms of talking south versus minus, or west for longitude minus. This is the location of Buenos Aires, which is located right here. Let's say their seismographs actually started going crazy and started drawing a seismogram. This is what the seismogram looked like. Talked about the P waves, the first packet of waves to get there, the S waves, the second pack, and the surface waves. Surface waves causing a lot of damage, but not really used in the epicenter location. Then what I did is I shrunk them down so I could actually put them next to, because if you take a look at this trying to figure out when this first P wave or first S wave happened, a little more difficult than if I shove them down here. They're going to have pieces of paper that they can actually measure distances like this and take it down. And it's a lot easier if you move them over to 0 rather than trying to actually do them mid-scale. But if you take a look at this, I asked them to try to figure out for Buenos Aires. I also talked about different seismograms having different color pens, so you can actually tell where this particular earthquake happened in terms of the timeline. Talk the difference between what's called horizontal motion, if you have their weight, the mass standing there without moving, and you have the paper so it can write down the record of the horizontal, and then if you make the thing vertical, you can do vertical motion with the spring. But time lag, the difference between the first P wave and the first S wave. Also talked about the SP curve, or this one actually says the PS wave curve, where we actually, if you started where the earthquake took place, point 0, the focus, all the waves would be sitting on top of each other, and as you move away, the P waves take off and the S waves take off, but because the P waves travel faster, the farther they travel, the more distance there is between them. So we have to figure out where the first P wave is, and we figured out it was 4 hours, 8 minutes, and 50 seconds. The first S wave, 4 hours, 11 minutes, and 25 seconds. So we're going to try to subtract those two. They actually told me that they couldn't do this, so we borrow one from there. We put 60 seconds in there. We can end up with 85. 50 minus 85, 35. 10 minus 8 is 2. 4 minus 4 is 0. Time lag is 0 hours, 2 minutes, 35 seconds. And then they went to their SP curve. They drew a line, I hope, which was and this was difficult to do also, 2 minutes and 35 seconds. They have a tough time actually trying to figure out where this designation actually goes. Then they take that line, they slide the bottom of it up the P wave, the top of it, they're trying to match it where the S wave is, and that line actually happens right here, and that coincides with about 1,200 kilometers of travel. So a time lag of 2 minutes and 35 seconds has a P and S lag of 1,200 kilometers distance. Then I asked them to go to this site, and I'll show that to you. Actually, I won't show you the site, but that site actually takes you to something that looks like this, where they're supposed to put in Buenos Aires. They're supposed to put in the negative latitude, the negative longitude, and the radius of 1,200, which I did in this picture. And as soon as you put that in there and hit enter, it draws a circle around Buenos Aires, which is 1,200 kilometers in radius. And then we talk about where did the earthquake happen, and it happens anywhere along this red line. So where do you send help? Are you doing a tsunami up here in southern Brazil? You're actually doing one down here in Argentina. You're sending help up here in Paraguay. Is it over here in Chile? Where the heck is all this stuff? So what they're saying basically is the earthquake could happen anywhere along this red line. So what do you need? You need to do triangulation. So we do Buenos Aires, we do Comodoro Rivadavia, I butchered that one, and then we're also going to do Santiago. Okay, so time lag, we end up 4 hours, 8 minutes, 55 seconds, and we go here, and this is 11, 12, 13, 14, 15, so 11, almost 30. First P wave, S wave, time lag 2 minutes and 35 seconds again. So these are actual equidistant away from the earthquake. And then looking at this seismogram, we can see that Santiago is actually the first one, the first of the three to get the earthquake, so they're the closest because this P wave and S wave distance is so short. In fact, the S waves actually come in before the P waves have settled, unlike that one and that one. So this one is at 5 minutes, 6 minutes, and 40 seconds. This one is at 7 minutes and 20 seconds. And if you do see that, that's 20 seconds to get to 7, plus another 20 seconds. Time lag for that one is 40 seconds. Then what they're supposed to do is take this, put that 1,200 meters that we got the first time, do it for this city, which was the same time lag, same distance, and then do the next one for 40 seconds, slide that up, and we notice that it's a little high there, but it's also a little high there, so it's sitting right there about 220 kilometers, which I'm going to fill there. Then we take that distance, put in the information for the three cities, put in the radius, and we'll put 220 in for that one, but there's that second one. Notice that they're the same, and we actually get 2 points where the earthquake, did it happen on land, did it happen in the ocean? We don't know yet until we put Santiago's. So notice Santiago is actually the closest to it, so it's probably not going to be that one. It probably will be this one. And when we do it, we actually do see that they get really close. Now, chances are you're not going to get it perfect, so what we do is we have this little triangle, and we say that the earthquake happened there. And you can see there are some cities around here, so I'm going to put the X marks the spot in that location. And now the question is, do we need to send help? Is there no problem, or is there a problem? And I'm not going to stop here because I really want to do the next thing. Next thing we got to do is figure out the Richter. How much energy, how much power did this earthquake have? And to do that, we need the amplitude. So we need to measure from the center line on the surface waves. We need to find the biggest one. And so I'm going to draw that red line up there to be that height. And I'm going to move it over there, and just to make sure, I'm going to put it down here, and you notice that it's higher on the top. So I'm going to go up, and I'm going to say that this is 22 plus, a little bit more than 22. Then do the same thing for the other two cities. Mark it, come up. Looks like 20, there's 22, so that's going to be like 21 seconds. And then this one is 18, looks like almost 1900, and a little bit more because I had to drop it down, and pixelation on these things is weird. So if you notice that that one's up a little bit more, so it's a little more than 21, just like the other one was a little more than 22. So 1950. Then you go to this nomogram. This is actually going to be for magnitude. On this side we have distance in kilometers, this side we have amplitude in millimeters, and here we have the Richter magnitude. And if we actually go to 22, 22 would put it, there's 20, 30, 40, 50. 22 is going to be about right there. And then we go to 1200, which is, there's 10, 11, 12, 13, 14. So this is about 11 or 10, 25, 11, 25. So I'm going to slide it up to like that location right there, down to that location right there. It crosses at a magnitude of 7. Notice this is almost the same line, 7. And then this one I'm going to go down to 220, which is going to be about right there. Go up to 1950, which is going to be up here. And if you put that on there, we're also going to get, it's not quite at that location, but we're going to get about a 7 there also. So we have a magnitude 7 earthquake, and the question is do we have to send data and help? The answer is a 7 magnitude quake is pretty bad. Okay, well, thank you very much for stopping by. Appreciate it. 11-minute video. Much better. Bye-bye.